Today we are talking about 5.1, using transformations to graph quadratic formulas, and 5.2, properties of quadratic functions in standard form. So we're going to combine these two over the next few days. Okay, so we have a quadratic function. Standard form is that top one there. You have seen standard form since we've been factoring. We have vertex form, which is f of x equals a parentheses x minus h parentheses squared plus k. Okay, vertex form actually tells you your vertex, and standard form tells you some other information. We'll get to that here in a minute. So here's our parabola. It's the graph of a quadratic function. It is U-shaped. Okay, it looks like this. This is what we call a parent function. So if it started at 0, 0, this is what the original would look like. Now they're going to move up and down and left and right and turn upside down and all these things. And we're going to talk about that as well. So you got some words here. A vertex is the single highest or lowest point. So on this graph, here is your vertex. Okay, it's the lowest point right here. That's your vertex. Okay, it's written as hk. So your h is your x value and your k is your y value. Okay, the vertex will always lie on the axis of symmetry. So an axis of symmetry here is a line through the vertex of the parabola that divides the parabola into two congruent halves. So we write it as, or it's x equals h. When in standard form we use that formula that x equals negative b over 2a. It's drawn as a vertical, dotted vertical line. So let me get a different color. So on here, my axis of symmetry is drawn right here. So our vertex lies on that, and so if I were to take this graph and fold it in half this way, this part matches this part exactly. They're congruent. Some more things we need to know. For either vertex or standard form, we're looking at our A. If A is positive, so that first, your A right here, or A right here, if A is positive, it opens up like our graph that we just looked at did. If it's negative, it opens down, so we would turn our shape up and it would look like this. For standard form, the C, the last number is the y-intercept. So we're going to use these things all in here, from the axis of symmetry down to here, to tell us some different things about our graphs here. Okay, so example 1. State the axis of symmetry, vertex, and whether the parabola opens up or down from the vertex form. So we can tell it's vertex form, first of all, because there are sets of parentheses here. So we are going to first look at each one of these. Does it have your A? Remember, A, if it's positive, opens up. So that's a positive 2, so that opens up. Positive 1, right? So it also opens up. It's a negative 1/2. This one's down. This one's a positive 4, so it's also up, sorry. Okay, so that's how we tell whether it's up or down, was this first number right here. Okay, your axis of symmetry, we're going to write it as h equals a number. So our formula is this h right here, and notice that's a minus h. So really when you're doing an axis of symmetry, it is the opposite of the sign you see. Okay, so we have our h is this one right here. So if that's positive 2, we want to go opposite of positive 2, which makes a negative 2. So h on B, if that's a negative 3, we really want opposite of negative 3 is a positive 3. On C, h is a positive 5, so opposite of positive is a negative 5. And on D, it's a negative 6, so opposite of that, h is a positive 6. Okay, so if it's in vertex form, we're literally just taking numbers out of here and putting them with our h. Now we've done our axis of symmetry, we've done our opens up or down, so we now need our vertex. Well, these numbers right here, those are all your x values of your vertex. Your y values come from these numbers out here. And y values are going to stay exactly the same. So that negative 3 is your y. Let me close it. That positive 1, that negative 8, and that 3. So these are all your vertex right here. These are your axis of symmetry. Sometimes we call them AOS for short, and whether it opens up or down. So if they're in vertex form, super easy to do those things. Now standard form, for example, 2, we still need the axis of symmetry, vertex, whether the parabola opens up or down, and the y-intercept. These two are super easy, and these two are not hard, they just require some calculations. So once again, up or down, looking at your numbers. Positive, so up, positive 1 we don't see, so up. Negative 4 is down because it's negative. Negative 1 squared is also down. Okay, now your y-intercept, okay, your y-intercept, your C here, is going to be 5, because it's your back number. Your y-intercept is 6 because it's your back number. Negative 3 and positive 3. Okay, or if you wanted to write C equals instead of y-intercept, you could do that. Okay, now remember I said the other two, the axis of symmetry and the vertex, aren't hard, we just have to do some calculations. We have to go back to this formula, x equals negative b over 2a. Remember, our axis of symmetry is referred to as an h, so h equals negative b. B is your middle number here. So negative 4 over 2 times, and our a is 2. So a, b, c. So negative 4 makes a positive 4. 2 times 2 is 4. 4 divided by 4 is 1. Okay, same thing on b. We need h equals a negative, because it's always got a negative. And that's a negative 4 again. Negative 4 over 2 times the 1. So if we do this, that's positive, and this is 2, right? So 4 divided by 2 is 2. Now this one, h equals our b, our b is negative 12. So negative, because it's already negative, negative 12 over 2 times, and our a was negative 4. So double negatives make that positive 12. 2 times negative 4 is 8, so we've got 12 over negative 8. And then 12 over negative 8 makes a negative 3 over 2. Last one for our axis of symmetry, h equals negative 2 over 2 times the negative 1 from right here. Negative makes a positive 2 over negative 2, which equals negative 1. Okay, now our last step, we have to find our vertex. Okay, you're going to take this is your x value, you plug it into your equation, and then we're going to be able to find our y value. So we've got a 1 here, right? So we have, our formula was 2x squared, so 2 parentheses 1 squared minus 4 times 1 plus 5. So if I plug that just straight in my calculator, 2 times 1 squared minus 4 times 1 plus 5 is 3. So my vertex is 1, 3. We are going to do the same thing for the rest of these here. So we had 2. So here's our formula. So we've got 2 squared minus 4 times 2 plus 6. 2 squared plus 4 times 2, 2 squared minus 4 times 2 plus 6 is equal to 2. So our vertex is 2, 2. Okay, we've got this one. So negative 4. Our x was negative 3 over 2 squared minus 12 times negative 3 over 2 minus 3. Okay, negative 4 times negative 3 over 2 squared minus 12 times minus, 12 times negative 3 over 2 minus 3. And that gives me 6. So this vertex was negative 3 over 2, 6. Do the same thing with that negative 1 in this formula right here. So negative, now that negative 1 over here needs to go in parentheses. So negative 1 squared minus 2 times negative 1 plus 3. So negative 1 squared minus 2 times negative 1 plus 3. And that's 4. So this vertex is negative 1,